Some recent NASA reports show that the Earth has been getting greener during the last 35 years, and it might be due to the increase of CO2 in the atmosphere. The discovery of the Earth getting greener has led some people to defend the belief that carbon dioxide emissions are saving the planet. One of the faces of this movement is Matt Ridley, a British politician, journalist, and biologist who claims to fight against the distortion and betrayal of science. He stated, "I have come to the conclusion that the risk of dangerous global warming, now and in the future, has been greatly exaggerated, while the policies enacted to mitigate the risk have done more harm than good, both economically and environmentally, and will continue to do so." In this video, I will explore some of Ridley's argument and try to respond to them using the studies of Charles David Keeling and Dr. Campbell. Before we start, I'd also like to precise that my beliefs are more aligned with Dr. Campbell and Keeling, meaning that I might be slightly biased. Still, I will try to be as objective as possible.
My argument is simply that the planet, surprisingly, is getting greener at the moment. It's getting greener because of carbon dioxide, because of climate change, because of the fact that we're needing less land to produce our food. And that greening is actually good news.
That greening isn't actually good news. Here's why. According to Professor Rangamai of Boston University's analysis of NASA's data, there has been a 14% increase in green vegetation on Earth during the last 30 years, and 70% of this increase could be due to carbon dioxide fertilization. Carbon dioxide fertilization is the process in which a higher concentration of carbon dioxide in the atmosphere leads to higher rates of photosynthesis. However, the cause of the greening isn't 100% proven. Despite this, it definitely sounds fair since CO2 is one of the key elements to photosynthesis. Since for a plant to photosynthesize, it needs water and carbon dioxide to create glucose and oxygen. So in conclusion, it would mean that more CO2 would be beneficial for plants since it is needed for their growth. However, it might not be so simple. What would make an increase of plants interesting is their capacity to absorb CO2. To sum it up, more green on Earth would mean less CO2 in the atmosphere. But trees don't only absorb CO2, they also release some through respiration and when they are destroyed. Additionally to defeating the purpose of why we would want more trees, this increase in CO2 can also be quite bad for the plant itself. In regions with higher concentrations of CO2, plant leaves get thicker, which allows the plants to conserve its water longer. Although it doesn't sound too bad at first, it is quite devastating. Water exchanges in plants are done through a process called transpiration. This process is vital to the plant. First, it is through transpiration that a plant regulates its temperature. It's the evaporation process of the water leaving the leaf that cools it down, and not only the water being in the leaf. Secondly, there is a limit to the amount of water a plant can hold. And if the leaves are full, the plant cannot renew its water, preventing it from getting the nutrient it needs from the soil. Although such attributes could be interesting for plants living in dry areas, most plants wouldn't benefit from thicker leaves. But despite all of this, the facts stay unchanged. The planet is getting greener. But let's see if it's a good thing. As Ridley presents his case in a video he released in 2013 called Matt Ridley on How Fossil Fuels Are Greening the Planet, he starts by presenting the Keeling curve. This curve was created by Charles David Keeling by measuring the amount of CO2 in the atmosphere since the 60s. However, it's not so much the increase in CO2 that is relevant to Ridley, but rather the amplitude of change of CO2 levels during winter and summer. Because this graph shows that even though more CO2 is released in the atmosphere during northern hemisphere's winters, more gets absorbed during the northern hemisphere's summers. And although this variation of amplitude isn't significant enough to cancel the rise of CO2, it was still important enough to attract Keeling's attention. So with the help of Frank and Magnani and a NASA reporter, Keeling discovered that this variation of CO2 levels in the atmosphere might be due to an increase in green vegetation on Earth that would itself be caused by the increase of CO2 in the first place. Still, despite this greening, the CO2 levels are still rising, leading to many important environmental problems such as global warming and ocean acidification. So here we're starting to find out that perhaps the increase of global vegetation isn't so good if it comes with an increase of CO2, because all this excess of CO2 is not being absorbed by this increase of trees. So climate change remain growing. Now, here are a few quotes from Keeling's autobiography where he states his opinion on CO2. I believe, however, that a more prudent attitude would be to heed the rise in atmospheric CO2 concentration as serious, unless proven to be benign. I am convinced that temperatures are rising significantly, not just from viewing temperature data, but also because the atmospheric CO2 record makes any other interpretation difficult. Whereas Keeling still considers CO2 to be dangerous, Ridley, on the other hand, praises CO2, saying it is good for the planet. To sum it up, with the same data, Keeling and Ridley seem to be drawing completely different conclusions. Ridley connects the global greening to the increasing amounts of CO2 in the atmosphere. And whilst it is true that some plants grow better in higher CO2 concentrations, it might not be as rejoicing as one might think. The problem with rising CO2 levels is that the planet will get warmer, oceans will get more acidic, leading to the disappearance of many species, including our own, eventually. Then Ridley talks about the man-caused extinct species since the 1500s. But the funny thing is that the number he brings up conveniently excludes plants, fishes, species living on islands, this time for the good reason that most of these species went extinct due to the introduction of other species in the ecosystem rather than climate change. And insects. So excluding all these categories, the amount of man-caused extinctions is only 9. And he concludes that therefore we are not currently in a mass extinction. Though this number might not be incorrect, he shouldn't forget all the extinctions excluded from that number, from all the categories I said earlier. They are still relevant when it comes to measuring a potential mass extinction. According to the IUCN Red List, at least 900 species have gone extinct over the last 500 years. This represents about 1% of the world's species. It includes 85 mammal species, 159 bird species, 35 amphibian species, and 80 fish species. Additionally, since we don't know about all of the world's species, it's likely that some have gone extinct without us even knowing they existed in the first place. Moreover, the IUCN Red List has evaluated that 35,765 species are threatened with extinction in 2020. So if we look at these numbers, are we looking at a mass extinction? The technical definition of a mass extinction is determined by 2 metrics: magnitude and rate. Rate measures how quickly the extinction happens, and magnitude, how many species went extinct. For an extinction to be considered a mass extinction, we need to lose more than 75% of species in a short period of time, around 2 million years. So, if we lost 1% of the world's species in the 500 last years, and if extinction continues at the same rate, it would take us 37,500 years to lose 75%, which is much faster than the million years of previous extinction events. However, this number considered that the extinction rate stays at 1% each 500 years. This might not be the case, because extinction rates have been increasing during the 50 last years. Ridley's last argument is that fossil fuels are good because countries which produce energy from it don't have to use biofuels. Although I do agree that biofuels are terrible for the environment because of the deforestation they cause, it doesn't make fossil fuels any better. And he is forgetting all the other alternatives, such as other renewable energies and nuclear energy. In conclusion, it is safe to say that carbon dioxide isn't saving the environment. Or at least if it is, it hasn't been successfully proven yet. It might be helping some plants for sure, but ecology isn't as simple as this. The benefits CO2 has on plants unfortunately doesn't hinder all the damages of climate change, which we all know are devastating. Despite that, the nuance Ridley brings is an interesting one that deserves to be addressed. I believe it is important for people to question the status quo. However, I don't think it should be done in spite of all the studies that have been done in the past decades, but in addition to them.